first thing that we will start, that the relations between EMF and terminal potential difference. That means that is nothing but the relation between EMF and terminal potential difference. What does it mean? That means that we are consider a cell of EMF E, and the cell has internal resistance R that is connected to an external resistance capital R. That means if we consider that is a battery and this is the corresponding internal resistance, and that are connected to the resistance that is R, and that is a small r, and you can say that that can be treated as a that is nothing but the difference. If we measure it across this, that means if we measure here, there is a EMF E and as well as a internal resistance that is flows, that is actually connected with the battery. So that means, say this is nothing but E, and the voltage that you measure, that means this one, that is nothing but V, capital V. That is nothing but the terminal potential difference. That is V is nothing but, you can say, terminal potential difference. So we know the current through the circuit, if this is I, that is the current through the circuit. So I is nothing but, you can write the potential divided by R plus R, or you can say E is equals to IR plus IR. So the thing is that since external resistor R that is connected parallel to the electrode of the you are measuring this, that means you are measuring the voltage across this, that means that is nothing but you are measuring the voltage across capital R. So that means what we can write, this is the potential difference, that is nothing but V is equals to IR, and if we place this, that means we are just placing IR instead of V plus IR we can write. So V is nothing but E minus IR. This is a small r. V is equals to E minus IR, and this shows the terminal potential difference of the cell that is less than the EMF of the cell. What is this? This is nothing but the terminal potential difference that we measure actually. That is nothing but terminal potential difference of the cell that is, you can say, less than the EMF of the cell, that is nothing but less than EMF of the cell. And if you want to find what should be the the value of the internal resistance, because it may ask that what should be the value of internal resistance. So if you want to find the value of the internal resistance, then we know the value of I is equals to E by R plus R. Now if we put this, because we know that V is equals to IR, so we can write in place of I, we can write ER by R plus R, that is V. So the small r can be written as E by V minus 1 multiplied by capital R. That is nothing but the internal resistance of the circuit. That is internal resistance of the circuit. Now the question is that when the cells are connected in series and when the cells are connected in parallel, that means we are saying that identical cells, you know, identical cells in series. If identical cells that are connected in series, that means this is the cells, this is internal resistance, this is cells, it is internal resistance, that is cell, that is internal resistance, and it goes on like that. And say this is connected to an external resistance, that is capital R, that is E, that is R, that is also EMF of the cell, that is R, that is also EMF of the cell, that is also R, and the current is flowing like that. So what we can say equivalently, what we can write from that, equivalently what we can say that in that particular case that can be equivalently represented, by, if we replace it, then this is nothing but N into E, and the resistance is nothing but, because all the resistors are connected in series, that is nothing but N into R, and this is the, the external resistance R. So the thing is, if we want to find the current flow through the circuit, it is nothing but, it is, effective EMF and divided by the equivalent, equivalent, resistance, equivalent resistance, and it is nothing but Ne by, this is capital R by Nr. We can write like that. So this is the case, that means that is nothing but current if the identical cells are connected in series. And we can consider the cases that if we know that capital R is greater than equals to Nr, that means external resistance is very very large compared to the effective or total internal resistance. That means we can write R plus Nr, equivalently you can write as a capital R. So the current I can be written as Ne by R, or you can say it may be possible. And what is E by R? That E by R is nothing but, current due to a single cell. That means total current that is flowing through the circuit is nothing but the N times the current due to single cell, that we can say. And if the value of R is much less than Nr, then what we can write Nr, that can equivalently written as Nr, or you can say I can be written as Ne by Nr, that is nothing but E by R, which is equals to the current due to a single cell. That means if a large number of cells in series that are connected to a very small external resistance, then the current from this cell will be equal to the current due to a single cell. That means there is no use of such a combination of cells. That means you should, use the external resistance value. Now if we say that different cells that are connected, in series, if there are, different cells that are connected in series, then also you can find the same way. That means, the total resistance of the circuit, that should be written by a formula. And there should be, if you are considering that the EMF are connected in, different directions, that means what we know, that means if we are considering that there are different cells, that is different cells in series. So if the different cells are connected in series, that means this is say E1, this is say R1, this is say E2, this is say R2, that is connected like that. Then what we can say that the total equivalent resistance, equivalent, EMF of the cell, that is nothing but E1 plus E2 dot dot dot, that is En, and the total equivalent resistance, that is internal resistance, that is Rn. So the thing is that we can make a formula, that means if of the, if the polarity of the M cells, that means if there are N cells, and if polarity of M cells out of n cells connected in series with external resistance, with external you know resistance R is reversed. That means they are connected in reverse. That means, say one cell is connected like that, another cell is connected like that, and it goes on like that. These are connected like that. If the cells, that means out of, if the polarity of the m cells out of n cells, that means total number of cells is n, and among which m cells are connected in series with an external resistance, then you can say the the if with external resistance R is reversed, then the equivalent EMF, if we say the equivalent EMF, that is nothing but n minus 2m into E, and the net resistance of the circuit, that is remains same. That means this is nothing but the capital R multiplied by NR. So that you should you have to remember the thing, that if the polarity of m cells out of n cells that are connected in series with external resistance R is reversed, then we can say the total equivalent EMF of the circuit is n minus 2m into E. Now if the cells are, I am coming to other formulas, but after completion of that, that means if the cells that is connected in parallel, if the cells that is connected in parallel, that means if the if the identical cells are there, that means this is identical cells, that means this is E, this is R, say that are connected like that, that means this is E, this is R, and also that is E, that is R, this is E R like that, E R, and that is connected like that. There is an external resistance that is connected like that, and so the current is passing through that. So here since it is a parallel connection, that means E effective is nothing but E, and if we find the R effective is nothing but R by M. So current is nothing but the total EMF by total resistance, that is Rm plus R. So you can say, if you solve it, then R plus MR. This is nothing but the current when we are connecting the identical resistance. And also you can do it by a similar way. That means that you can do it by similar way, means uh, if you want to find that the value of small r would be greater than capital R and all those stuff, then you have to neglect a thing and you can derive the results. Now the thing is, if the different cells in parallel, if the different cells that are connected in parallel, if you say the different cells, that means that is different cells that is connected in parallel, and what is the meaning of that? That means if this is E1 and resistance, that is also E2 and corresponding resistance, say this is E1, this is R1, this is E2, this is R2, and the thing is that if you solve it, then you can find that the equivalent resistance is nothing but E1 R2 plus E2 R1 by R1 plus R2, and of course R equivalent is nothing but R1 R2. This is parallel connections, R1 plus R2. So that uh, if we want to find the current, that should be like that. So the thing is that if we say generalize, there are m cells, if there are m cells, let there are m cells of say EMF E1 E2 dot 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 EM, and the internal resistance, that is R1 R2 dot 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 Rn, that is the internal resistance, then you can find the total equivalent resistance that can be written as 1 by R1 plus 1 by R2, that is 1 by Rm, and the equivalent the EMF, that is nothing but E1 R1 plus E2 R2 dot 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 EM Rm multiplied by R of equivalent. So that is the corresponding formula by which we can find if the cells are different. That is the corresponding thing. And the another thing is, if we are use mixed grouping of cells, that is mixed grouping of cells. What do you mean by mixed grouping of cells? That means there are series connections and that is also connected in parallel like that. That means if we consider this is E, this is R, say this is E, and say this is R, and also say this is connected like that. There is a other than that, this is a resistance, this is a battery, this is a resistance, like means that are connected in series and parallel. That means, and this is a capital R, and there are M rows, there are M rows are available. So what we know that if we consider this, that means total EMF of the n cells in a row. There is a n cells in a row. There are say n cells. That means what we know that EMF of n cells in a row, that is nothing but n into E, and that is the effective resistance, because since if the resistance of this is if the EMF of this combinations of the cell is any and all these are connected in parallel, so that means the EMF of the circuit you can say that is also any. Now if you find the effective effective for each cell, if there are n cells and n cells each has resistance smaller than the total resistance in each row, that is nr. So if we find the equivalent resistance 1 by nr, 1 by nr up to m, so you can say m by nr. So R effective you can say nr by m. And the equivalent circuit is a mixed grouping of cells and is equivalent to a single cell of EMF any and the internal resistance of nr by m, that is connected to an external resistance capital R. So if you want to find the current, that is total EMF is any, and the total resistance, that is capital R plus n small r by m. So you can find m and E by mr plus nr, that we find. And if we want to find the when the current is maximum, that we can express it by using a whole square formula. That means say root of r mr minus root of r nr, that whole square plus root of r 2 m n r r, and the current of the circuit will be maximum. Then the current of the circuit is maximum, and it will occur when you find the value of mr that should be equals to value of nr, because that is the whole square formula. And if you want to find the current is maximum, that means that part is equals to 0, or you can say root over mr minus root over equals to minus root over nr, and that is nothing but nr by m. So what we find, in order to set the maximum current in the circuit, the mixed grouping of cells must be done in such a way that the external resistance that should be equal to the effective internal resistance of all the cells. That's nothing but the effective, you just say this is nothing but R effective, which is NR by N. You will find R value, capital R value should be. That means when the external resistance value should be equals to R effective, that means the total effective resistance of all internal resistance, then you will find that the current through the circuit, that is maximum. The current through the circuit, that is maximum, that we actually found from the from the mixed cells equations. So that is the one that is the one part of the sections where we will find that how the mixed cells are connected, and we also find the relations between them. That means there are certain questions that will come, and that should be, I think, easy. That means it may be the questions comes like that, say it's like that, say the 100 cells, the questions if they comes like that, the 100 cells, each of EMF, 100 cells each of EMF, that is 5 volt, and internal resistance, and internal resistance, that is nothing but 1 ohm, to be arranged to be arranged to produce maximum current, to produce maximum current in a 25 ohm resistance. Each row contains equal number of cells. Each row that contains equal number of cells, find the number of rows. That is the question. That means 100 cells each of EMF 5 volt, and the internal resistance that is given 1 ohm, that is connected.
Sir,
Yes,
sir, it formula দেখো তো একটু।
এটা
Okay, sir.
তাহলে বলো দেখি, এটা তো সোজা।
Sir, 2.
Yes, that should be 2, because you know that Mn is equals to 100 and current will be maximum if R equals to NR by M. So you just put the value and you will get the answer. And so N is equals to 25 M, and if you put this into this, you will get that N value is 50 and M is equals to 2. So that is the one of the questions that may come, and let's see whether any questions that is come from NEET, then we can solve this, at least one questions that is coming from combinations of so it is given in one questions, 2015 or 16. The thing is, the question is given like that. You will see that the question is that came in your examinations in NEET. So in a given circuit, say each cell has an EMF of 0.15 volt and internal resistance, and internal resistance of 0.25 ohm. So you have to find the current in the circuit. So it is given this is a resistance, and they will give dot dot dot, and they will say there are 10 rows, and these are connected to a resistance that is 10 ohm. Options is given 0.12, that is 0.012, C is 0.045, and D is 0.45 ampere.
স্যার
বলো।
স্যার এখান থেকে ফর্মুলা বেসডেরই বেশি আসে তাই না?
হ্যাঁ, ফর্মুলা বেসড আছে।
স্যার 0.045
0.045, yes, that should be 0.045. Okay, so the thing is that I think you can solve it. So yes, so the thing is that, so you just put it into formula and you will get the answer for that. That means the formula is nothing but I is equals to n, we are finding ne, that means divided by this r plus nr by m. So you just put it into the formula and you will get the answer. That is nothing but that. Okay, let's, whether you can solve it or not, let's try it. That will come in some joint entrance. So the question is, four cells, each of EMF, that is E, and say internal resistance, and resistance internal resistance is R, that are connected in series across an external resistance R. By mistake, the question is, by mistake, one of the cells is connected in reverse, then the current in the external circuit is, that is 2E by 4R plus R, 3E by 4R plus R, 3E by 3R plus R, and D is 2E by 3R plus R. So that is the questions.
স্যার এ
কত হচ্ছে অপশনস? এ হচ্ছে, তাই বলছো তো?
হ্যাঁ স্যার।
ওকে, কিভাবে
স্যার ওখানে ওই যে ফর্মুলাটাতে যে দিয়েছিল একটা রিভার্সাল ফর্মুলা ছিল, 2E করে নিতে হবে। এমনিতে স্যার মানে মানে টোটাল মানে R1 প্লাস R2 প্লাস R3 প্লাস R4 করতে হতো, ওটা টোটাল 4R হতো। তারপরে ওটার সাথে ইন্টারনাল রেজিস্ট্যান্সটা যোগ করতে হতো, ইকুইভ্যালেন্ট রেজিস্ট্যান্সটা পেতে হতো। হ্যাঁ স্যার, এই ফর্মুলাটা।
If you apply this particular formula, then the answer will come out. Okay, so here the effective resistance, effective EMF is 4e minus 2e, that is 2e, and total internal resistance is nothing but 4r. So the same thing, that means in your diagram it is given that there are four cells that each of EMF E and internal resistance R are connected by in series. So in that particular case, if we use this particular formula, then the N is nothing but 4, and only there is only one mistake. That means the value of M is 1, N is 4, and the thing is E is E, so that means that is nothing but 2E, and R equivalent is nothing but this is R, and there are 4 cells, that means 4 cells each has resistance R, and from that you will get the current, that is 2E, nothing but 4R plus 5. So that is the corresponding formula basis. Only last questions that we solve from this. So in that particular case, the answer that came, that is options A. Now whether you can solve it or not, let's try it. The next questions, the question is 10 identical cell, 10 identical cells that are connected in series are needed to hit a wire of length 1 meter and radius r by 10 degrees centigrade in say time t. How many cells will be required to hit the wire, of length 2 meter of the same radius, 2 meter of the same radius by the same temperature in say time t, and say this is 20, b is 30, c is 40, and d is 10. So what should be the answer of that? এটার তাহলে অ্যান্সারটা হলে আমায় বলবি। So in that particular case, so we know that R equals to rho L by A. So we just put that is R equals to rho R square. Now there are 10 identical cells that are connected in series. You needed to heat a wire of length 1 meter and radius R by 10 degrees centigrade. So that means what I am saying, that means that is this is means 10 identical, you know if this is E and E, they are connected like that, and the length of the wire, that is 1 meter, and 10 cells of EMF E that are connected in series. So what we know, that heat, that means heat is nothing but, we know that is V square by R multiplied by T, that is the dissipation of power. And in that questions, how many cells will be required to heat the wire of length 2 meter of the same radius by the same temperature. That means that is the power loss. We know power is equals to V into I, and if the time is T, that is nothing but V into I into T, or you can say I square R T or V square by R. you know if the V equals to IR, then that should be I square RT or V square by RT, whatever be the thing. We will see that in the previous class. So that should be equals to the M into S into temperature difference. And in the second case, since the resistance, if we say this is the corresponding first case, and in that particular case this V is nothing but 10 you know 10 E.
Sir, MST क्या? Sir, ये conversion টা কি হলো?
এই যে power dissipation is nothing but is equals to heat dissipation, এখানে তো তাই বলেছে যে how much heat will be, how many cells will be required to heat the wire of the length 2 meter of the same radius. That means যতটা হিট হবে, how much heat, হিটের ফর্মুলা কি, which is nothing but mass into specific heat into temperature difference. That is nothing but the power dissipation. That means that is due to power dissipation the heat is produced. So that's why you can equate this to formula. That means this is nothing but the power dissipation due to flowing through the current through the circuits, and that is equivalent to the amount of heat that is produced. Nothing but that. Whether it is clear or not.
Yes, sir.
So the thing is, this is
Yes, sir.
so V is nothing but 10E. That means there are 10 EMF of the cells are connected. So you can say that is MS into del T. You can say this is the equation number 1. And in the second case, you just see that the length of 2 meter. That means length is only and of the same radius. That means of course the resistance R prime, that is also rho into, this is nothing but 2 in pi r square, only the length part will be changed, and this is nothing but 2 into r, it is nothing but 2 into r. So in the second case I am saying that let there are n cells, each of EMF E that are connected in series, to heat the same wire, of say length, that is 2 meter, and in the same temperature. That means this particular formula we can write, there is n, this is EMF is same, so this is nothing but n e square, this is nothing but there is also a quantity, that is T divided by R, and that should be equals to 2m s into del T. And if you can divide it, then you will find then that, because the S part, del T part, and whatever be the thing, that will be cancelled out, and you will
Sir, ये same word টা কি হবে?
yes, একজন বলো।
স্যার বলছি যে ওই সেম ওয়ার্ডটাকে তো স্ট্রেচ করা হয়েছে না আরো ডাবল করে?
Required to hit the wire of length 2 meter. না না স্ট্রেচ করা হয়নি, লেন্থ 2 মিটার নেওয়া হয়েছে।
ও আচ্ছা আচ্ছা, ওকে স্যার, তাহলে ঠিক আছে। আর স্যার
তাই
লাস্টে ওখানে বোধহয় ডিভাইডেড বাই 2 হবে
কোনটা বলো তো?
স্যার এই ইকুয়েশনটাতে।
ইকুয়েশন 2 তে?
হ্যাঁ স্যার,
হ্যাঁ
লাস্টেরটা
স্যার।
বাই 2 আর হবে না।
ওকে, সো দ্য থিং ইজ দ্যাট এখানে তোমরা বলছো বাই 2টার ওই 2 আর আছে, তাই তো? ইয়েস।
হ্যাঁ স্যার, এটাই
হ্যাঁ
বলছি।
স্যার।
ओके, so the
सर
third
2m कैसे होगा 2m?
the mass is also, you know, if we consider about the mass, then that is dependent on length. That means if in the first one the mass can be written as, you know, pi r square into L, you can write like that, into density, whatever be the thing. So in the second
सर
case,
लेंथ डबल तो मास डबल।
because length is double, you just see that because the r
यस
will be same, everything
ओके
is
सर।
same, so you can say the mass can be, m2 is nothing but 2 of m1, so that's why you have to, the mass is double and that is 2r, because resistance is 2r. So if we just divide it, then you will get n square by 200, that would be equals to 2, or you know n square equals to 400, or you know n is equals to 20. So the answer is n equals to 20. So I'm just giving you the hints that that type of questions is came in your NEET or some exam, competitive exam, from this particular, you know, topic, that is mixed cell. So now we will move to the next thing, that is nothing but the Ohm's law, and there is first thing that we should learn, that is nothing but the Kirchhoffs first law and second law, and you it may be that you heard the name of the law. The thing is that
স্যার এরকম লেভেলের ডিফিকাল্টি আছে?
এইরকম লেভেলে যা নিটের কোশ্চেন্স দেখলাম, এইরকম লেভেলে, বুঝতে পেরেছো? কারণ এই টপিক থেকে এর বাইরে হয় না, বাট দ্য থিং ইজ দ্যাট জয়েন্ট এন্ট্রান্স অ্যাডভান্সের জন্য হয়তো আরও কিছু কোশ্চেন্স আমি বেছে রাখবো, সেইগুলো একটুখানি করতে হবে। বাট মিক্স সেল থেকে আই থিঙ্ক তার বেশি কিছু আসার সম্ভাবনা নেই, তার কারণ যা দেবে ইটস ফর্মুলা বেসড। ওকে, সো আই থিঙ্ক তার মধ্যে কোনো প্রবলেম হবে না। যেটা প্রবলেমেটিক বা যেটা দিয়ে অনেক রকম ডেভিয়েশন অফ কোশ্চেন্স আসতে পারে, দ্যাট ইজ ফ্রম Kirchhoffs law, because there are lots of variations of questions can come from Kirchhoffs. So the thing is that, so the first law, that is called, you know, Kirchhoffs. This is the first law, or you can say rule, whatever be the C, that is nothing but the junction law, or you know, Kirchhoffs current law. That is Kirchhoffs current law. This is the Kirchhoffs first law, junctions law, or Kirchhoffs current law. And that is the simple thing, that means it, you know, states that the, you know, sum of all the currents, sum of all the currents entering at any point, entering, you know, at any point, or you can say junction, whatever be the, must be equal to the sum of all current. একটু হোল্ড করো, বুঝলে তো, একটু ঝড় উঠেছে, আমি জাস্ট একটুখানি 5 minutes. So the thing is that it states that the sum of all the currents that is entering at any point, that must be equals to the sum of all currents leaving that point, leaving, you know, leaving that point, and you know, that is nothing but a junction, or you can say that this is can be said in different way, that means the algebraic sum of all the currents, algebraic sum of all the currents that is meeting at a point in a closed electrical circuit is 0. That means total current is equals to 0. That means what you can say? That means, say this is a, say, resistance, a current will be coming like that. It may be, that is the, a junction point like that. So say this current I1 is entering the junctions, current I5 is leaving the junctions, current I2 is also leaving the junctions, current, say I3 will entering the junctions, and I4 will leaving the junctions. So what we can say from that particular figure, that I1 plus I3, because the total current that is entering, that means I1 and I3 that is entering, and then there are three currents that is leaving. You can say that is I2 plus I4, that is plus I5, or you can write the equations that I1 plus I3, say minus I2 minus I4 minus I5, that is equals to 0, or you can say summation of I equals to 0. So current entering the point that is taken as a positive, or current leaving the point can be taken as a negative. Then the total current, if you add it, that will be equals to 0. That means thus that the entering current entering the point that can be taken as positive, while current that is leaving the point can be taken as negative. So in your class 12, it may be that the current law is not used much, but the thing is, in competitive exam, that is a very useful formula. You can apply in different in different problems. You can apply the this current law, and that will be very much beneficial. And uh, if we draw the network,
স্যার
yes, follow.
স্যার জেনারেলি এটা রিভার্স হয় না সব জায়গায়, যে লিভিং দ্য পয়েন্ট হচ্ছে পজিটিভ হয়?
ডিপেন্ড করছে নোটেশনের উপরে, বুঝতে পেরেছো? মানে
আচ্ছা, মানে আগে মানে যতগুলো সার্কিটসও ড্র করেছি ওখানে তো লিভিং করছে আর কি।
হ্যাঁ হ্যাঁ,
আম,
বাট এখানে এই রিপ্রেজেন্টেশন ধরা হয়, তাতে কিন্তু ইকুয়েশনে খুব একটা ডিফারেন্স হয় না, জানো তো? মানে পজিটিভ নেগেটিভের ব্যাপার, তুমি যেভাবে ধরবে সেভাবে হবে, বাট এখানে সাধারণত এটাই ধরা হয় যে এন্টারিং দ্য পয়েন্ট দ্যাট ইজ টেকেন অ্যাজ এ পজিটিভ, অ্যান্ড that leaving the point is taken as a negative. এটাই সাধারণত এখানে ধরা হয়। সো তোমাদের বুকসে কি ফলো করা হয়েছে?
স্যার মানে আমি এখনো কেসিএলটা বইটাতে দেখিনি, কিন্তু বাকিগুলোতে তো ওই আগে যেরকম করছিলাম যে এন্টারিং দ্য পয়েন্টে হলে নেগেটিভ হবে আর লিভিং করলে পজিটিভ হবে।
বাট এখানে কিন্তু দেখো, এখানে আমরা কিন্তু এইটুকুই দেখি যে এন্টারিং দ্যাট শুড বি ইকুয়াল টু দ্য লিভিং। ওকে, এখন ইকুয়েশন ফরমেশন তুমি দুভাবেই করতে পারো। এটাকে নিয়ে মাইনাস I1 মাইনাস I3 ইকুয়াল টু 0 লিখতে পারো, অথবা এটাকে নিয়ে এসে এদিকেও 0 লিখতে পারো। বাট জেনারেলি current entering the point that is taken as a positive, and current leaving the point is taken as a negative ধরা হয়। এবারে দেখো, দ্য নিতে একটা কোশ্চেন এসেছিল। the difference is, the thing is that the question is, say, in the following network, in the following network you have to find the potential at O. Say this pictorial diagram is given. This is 4 ohm, this is a point B, this is a point O, this is a point A, there is 8 volt, resistance is 2 ohm, this is 2 ohm, that is C, this is 2 volt, and at B point that is 4 volt. So you have to find in the following network, you have to find the potential at O, and say the options that is given, that are the corresponding options that are given: 4 volt, 3 volt, 6 volt, and 4.8 volt. So if this type of questions are given, that is the thing where you can apply the KCL. That means what we can do, that using KCL, what we can say the current is coming here, because we don't know the potential, so we can take any directions. That means we can say the current is living in that particular direction. So what we can say, that IA can be is equals to IB plus IC. We can write like that. This is IB and this is IC. So IA, that means this is the current that is entering in the junction. If we consider about the junction O, then IN is the entering current, and IB and IC, that the two current that are leaving from the circuit. So what is IA? IA is nothing but current. That is if we say the potential at O point is VO, then what we can say, that is the 8, that means potential difference by the resistance, that is 2 ohm. We can write directly for the circuit. This is the VA, potential is 8 volt. Here the potential we take VO, and the resistance is 2 ohm. So current is nothing but 8 minus VO by 2. For IB, what we can say, that the potential is VO, and at B point the potential is 4, that is divided by 4 ohm, and plus that is VO minus 2, that is nothing but by 2. So the thing is that if you solve it, then you will get 16 minus 2 V0 equals to V0 minus 4 plus 2 V0 minus 4, and you will get the value V0, which is 24.5 equals to 4.8 volt. So you just remember, if you can solve the problem by using KCL, it always requires less number of equations compared to if you solve it by using KVL. So there is a term that is called, what I actually did, that is nothing but one of the method that is based on KCL, that is called nodal analysis. That is nothing but nodal analysis. And what is nodal analysis? You just find the questions may come like that: find the current in the say 3 ohm resistance for the circuit that is given. Say this is 2 ohm, and say this is positive, negative, this is 4 volt. Say this is 3 ohm, this is negative, positive, that is 2 volt. This is that is given, that is 2 ohm, and say this is 2 ohm, and this is say 4 volt. So this circuit is given, and you have to find the current in the 3 ohm resistance. That is nothing but this 3 ohm. This is a 3 ohm resistance. Basically, what the beautiful thing about nodal analysis, that we can take the current in any directions as per your wish. You need not to think of that. That means what the basic thing you can take, that current I1, say this is a 4 volt and this is a 2 volt, so we can say the current I1 will be flowing like that, say current I2 will be flowing like that, and current I3 will be flowing like that. I am not bothered about anything, any directions. We are just saying I1 will be passing through this branch, I2 will be passing through this branch, and I3 will be passing through this branch. And the thing is, I am just taking the potential that is the point number 1, and you know that you can say there is a ground, so this is the point number 2. So what I am saying, let you know voltage at 1 is say V1, say that is at point 1 that the voltage is V1. So if we consider for node 1, if we consider node 1, that is nothing but I1 and plus I2, that should be equals to I3. So for I1, what we can say, this is the I1, and you know that is the current, that is the battery voltage, that is the positive negative, and when we are moving this, when negative to positive, it is taken as positive, and in that particular, you know, it's battery, we are moving from negative to positive, that means two battery voltage should be added. And the thing is nothing but, this is nothing but the voltage is 6 volt, because the total voltage we are moving in that particular direction, and you know we are moving from negative to positive, it is also negative to positive, as we already discussed in capacitor or somewhere. When the battery is connected like that from negative to positive, that is taken as a positive. For that particular voltage, you will see that we are also moving from negative to positive, so that the total voltage is 6 volt, and you know that the potential at 1 is nothing but taken as V1, that is the potential difference, and the total resistance is nothing but 5. And if we consider I2, you just see here the potential is 4 volt, here the potential is taken as V1, so 4 minus V1 by 2, that is equals to I3. So here the potential is V1, and another point the potential is 0, that is in ground, so V1 minus 0 by 2. So what we can get, we can get, you know, by solving this only single equation, we will get the value of V1, and if we calculate it, the value of V1 should be, you know, 8 by 3. And if it is 8 by 3, the question is you have to find the current in the resistance 3 ohm, and of course the current through the resistance 3 ohm is nothing but I1 that we take, that means we have to find the value of I1, and already we know the value of I1 is nothing but 6 minus V1 by 5, so 6 minus 8 by 3 by 5, and that is coming out 10 by 15 or 2 by 3 ampere. So that is the thing, that type of questions can be solved easily if we consider, you know, the nodal analysis. That is the beautiful of nodal analysis. Like that, you can say that the questions may be coming that what should be the, you know, power consumption, say total, you know, find total, you know, power that is consumed by, you know, passive elements of the network. That the questions may come like that. And the circuit that is given, say it would be given like that. If the circuit looks complicated, but we can do the nodal analysis easily. In your NEET, I think that difficult circuit is also not be given. If you can solve it, you can solve any problem, I think so. So say this is a 20 volt, and say this is a resistance, and this is, you know, another resistance, and say this is a 1 ohm, this is a 0.5 ohm, say this is also 2 ohm, that is 1 ohm, that is 1 ohm, 1.5 ohm, like that. So that is the thing, that means you have to find the total power consumed by the passive element, that means you have to find the current, you have to find the current in each branch. So in that particular case, what we can think, in that case also we can think the current can be, we are not bothered about the directions, that means we are saying this is a battery, that means the current I1 will be flowing through this, say, you know, the current I2 will be flowing like that, because we are thinking that this is a 20-volt battery that is more generating the power compared to generating current than 15 volts. So we can say this is the current I2, this is this is I3. So that coming, you can name as per your choices. I am not bothered about the divisions, that I am just writing that I4, this is I5 and all those stuff. আমরা নিজের মতো করে লিখতে পারি, and let the voltage at point 1, say this is a point 1, that is the voltage is V1 that is taken, and say at point 2 the voltage that is taken V2. So I am considering at say node 1. You just say the current that is entering, you are knowing the current I1 and I2 is entering, and I4 is leaving. Now if we consider I1 is nothing but this is a 15 volt, and at the point 1 that the voltage is V1, so it is nothing but 15 minus V1 by 1 plus I2 is nothing but V2 minus V1 by 0.5, and I4 is nothing but V1 minus 0 by 1. So if you can solve it, you will find that we will get equations of V1 and V2, that is 15. We will get that equations. Now if we consider at node 2, if we consider at node 2, you are saying that I3 is entering and I2 and I5 are leaving. So you can write I3 can be written as I2 plus I5. And what is I3? I3 is nothing but what we can say, that is nothing but 20 minus V2 by 1, that is equal to V2 minus V1 by 0.5 plus you just see V2 minus 0 by 2, and if you can solve it, we will get another equations, J4 V1 minus 7 V2 minus 40. And if you get two equations, there is two unknowns, you can solve it. You can easily find the value of V1 and V2. Say V1 that will be coming out 37 by 4, and V2 is becoming out 30. This is the two answer. And from that, what's the value of I1? I1 I1 is nothing but 15 minus V1 by 1. You just put the value. V1 is 37 by 4, that will be coming out 7 point. So you will find the value of I2, you can find I3 and I4, and power means I square R, that means I1 square R1 plus I2 square R2, like that, and that is nothing but the total power consumed by the circuit. So the main thing that you should understand, that when we consider the KCL, the number of the circuits, number of equations is always been less comparative to the KVL. So if you just understand the KCL, you can solve many problems, and that is very nice. The KCL is more, if you can apply KCL, the problem the solve more easily. So now the next rule, I think it is clear to all of you, and the thing is that the next rule, that is nothing but KVL, that is Kirchhoffs second law, or that is Kirchhoffs second law, or the loop law, or KVL, Kirchhoffs voltage law. That is the thing. So it also states that the algebraic sum of all voltages, that is the potential differences across all elements. The potential, this is a voltage law, so that means the potential differences across all elements and EMFs of all sources in any closed electrical circuit is 0. That means the total voltage, the change in voltage, that is equals to 0. And the sign convention, that is also one of the important thing, that is called sign convention. That means, in a given electric circuit, and say that is the resistance R, say this is a point A and this is a point B. So when a resistor R is traveled in the directions of current, that means the current will be flowing like that, and we are also traveled in the same direction. The potential difference del V across the resistor may be taken as a negative. So when the resistor R is traveled in the directions of the current, the potential difference across the resistor may be taken as negative, and when a resistor R is traveled in the directions opposite to the directions of current, the potential difference is taken across the resistor is taken as a positive. That we know what I am saying. That means we are traveling in that particular directions, and del V is taken as a IR. And if the thing is that this is a point and B point, there is a resistor R, and the current direction is this, we are traveling in from A to B, then del V is taken as IR. And there is another rule that is already it's known to you. That means, if this is a positive and this is a negative, this is a cell E. That means in a given circuit, when a source of EMF E, say a cell that is traveled from negative to positive terminal, the potential difference across the source may be taken as positive. That means this is negative and this is positive, and we are traveling in those directions. That means that is taken as a positive E. And now if this is a positive and negative, and we are moving in that particular direction, that is taken as a negative E. That we already know. So the thing is that, so if we can say solve the problem, then I think that would be more clearer to you. That means, say this is a 2 ohm resistor, that is a voltage, that is 10 volt, and that is also another voltage, this is negative positive, this is a resistance, say resistance is 3 ohm, that is 4 ohm, and you say that is 1 ohm, and say it's like that. So the thing is that I can break the current like that. Say what we can break the current, that means you can break like that. That means if we say this is a 10 volt, that is a 4 volt, and if we say that from negative positive the current, this is I1, say, and at that particular branch, say it is divided into 2, you can say, if we say that is nothing but say I2, so we can say that is nothing but I1 minus I2. We can write that, because the current I1 will be coming, and it is divided into 2 parts, so you can write like that. So this is I1 minus I2, and here also I1 will be flowing, because I1 minus I2 and I2 will be add this, so that will produce I1, whatever be the thing. So I can break like that. So if we can say this is a loop 1, and say this is a loop 2, so if we consider this, that means we are applying KVL, and if you say that is the name of this loop A, say P, this is C.
सर
Yes.
सर ये क्वेश्चन क्या जॉइंट एंट्रेंस लेवल का है या फिर बोर्ड्स का है?
कौन क्वेश्चंस?
यही सर केवीएल का।
ये जो दिखा रहा हूँ
ये सर
ये बोर्ड में भी आ सकता है और जॉइन में, बोर्ड में भी आ सकता है, जॉइन में भी आ सकता है।
ओके सर, इसके टाइप का भी ना?
हाँ हाँ, इसका टाइप का।
ठीक है।
So when we are applying KV, say along loop 1, that means if we say along the path A, B, C, D, A, if this is the corresponding path, so you just see that we are moving in a directions, that is a that positive to negative. We are moving in a direction that is positive to negative. So what we can say, by taking the Kirchhoffs rule, what we
স্যার
can
নেগেটিভ থেকে মুখ করছে তো।
না, আমি তো এখানে লুপটাতে এইভাবে মুভ করছি, এ বি থেকে এদিকে এইভাবে মুভ করছি, তো এইভাবে লুপের
ও
ডিরেকশন।
হ্যাঁ লুপ 1, হ্যাঁ স্যার ঠিক আছে।
লুপ 1টা যদি আমি এইভাবে মুভ করি তাহলে তো আমি এই ডিরেকশনসটা কি, ব্যাটারি তো পজিটিভ টু নেগেটিভ উই আর মুভিং, তাই না? So if we moving from the directions in the particular directions, so what we can think of that? So the thing is that because the if we are moving in a direction, because it is given, it is taken as a rule that when a source of EMF, say cell a travel from the negative to positive terminal, the potential difference across the source may be taken as positive. And when a source of EMF is travel from positive to negative terminal, the potential difference across the source is taken as a negative. So in that particular case, since we are moving like that, we can say that is a minus 10 volt. We are moving there, you just see the current direction across. We are just reaching the you are reaching the resistance R3, and the current directions is I2, the current directions that is equals to I2, and we are moving in the opposite side, so that means what I am saying, that when the resistor R that is traveled in the directions of current, when a resistor R that is traveled in the directions of current, the potential difference across the resistor may be taken as negative. But in that particular case, what I am saying, that the current directions I2 is along these directions, and we are moving in the opposite directions. That means a resistor R is traveled in the directions opposite to the direction of current, then the potential difference across the resistor may be taken as a positive. So we can say that can be taken as a positive. What the meaning of that? That means this is voltage is 3 and current is I2, and again we are coming to this battery, and in that particular battery we are again moving from positive to negative. So when we are moving from positive to negative, that would be taken as a negative. So the thing is that voltage is 4 volts, so we are taking 4 volt. Again we are back there, in that particular branch the current is nothing but I1, and we are also moving in the opposite direction. That means we are moving in the opposite directions where the current directions and our loop directions is opposite. So you can say that is also taken as a positive. So 2 into I1, that is equals to 0. So you can say from that particular diagram, you can write that is 3 I2 plus 2 I1, that is equals to 14. In some books, if we taken as reverse, then the equations will come like that. So it is not an issue, you will always follow any one rule. So now if we take the loop 2, if we take loop 2, then we are moving from this direction, say D, C, F, E, D, that is the corresponding direction. And when we are moving this, you are just saying that this battery, we are moving from negative terminal to positive terminal, that means that is taken as a positive, that means that is 4 volt. Then when we count this resistance, the current directions is I2, and we are also moving in the same directions, we are moving in the same directions, currented directions is I2, and the loop directions, because we are also moving in the same direction, so we are taken as a negative, so that means 3 into I2. Now we are going this, and now the loop is coming in that directions, and you will see that I1 minus I2 is going downwards, we are moving upward, that is the opposite directions, that means you can say we can take it as a positive, that means 1. Yes, bolo
सर
bolo
सर ये हम थोड़ा सा सॉल्व किए, I1 का वैल्यू आ रहा है 3.33 एम्पियर, I2 का आ रहा है 1.83 एम्पियर।
I2 का आ रहा है 8 पॉइंट, देख रहा हूँ कितना आ रहा है पॉइंट,
1.83।
ओके देखना पड़ेगा यहाँ पे।
ठीक है सर।
3I2 plus I1 minus I2 is equals to minus 4, so you can say I1 minus 4I2 is equals to minus 4. So if you can solve it, that means it may be possible that you are multiplied by 2, and that means 8, and you just subtract it with equation number 1. You can subtract it, then that is 3I2, that is nothing but 3I2 plus 2I1 minus 2I1 plus 8I2, that is 14 plus 8, so that is 2I1 and 8 and 3 11 I2, that is I2 is equal to 2, I think so, that will become, so the current is I2 equals to 2. If I2 comes as 2, then if we placed in equation number 1, say this is 6, that means 2I1 is equals to 14 minus 6, that is 8, so I1 is equals to 4 ampere. So I1 is equals to 4 ampere and I2 is equals to 2 ampere, that will come out. So you can say the answer of this particular questions, that is nothing but that. So you can if we calculate like that, so the thing is that it may be possible that you will take the wrong directions of current, so don't worry if you take the wrong directions of current, then the thing will happen that the current value may come out as a negative, and the current value, if it is come out as negative, and then you can think that we are taking a wrong directions of current, so that is not an issue. Okay, let's solve one problem, because that is the best thing, and you will understand that KCL is more easier to solve than KVL, of course, but in some books you will follow either this thing, that means you are taking this is a negative and this is a positive, or you can take reverse way. But the thing is, whichever you take, you should take only one, that means you should follow only one rule, otherwise that will be create a mess. So the thing is that if we consider the Wheatstone bridge with stone bridge network, Wheatstone bridge network, that is the Wheatstone bridge network, and the current division is one of the important thing if we consider anything. That means Wheatstone bridge means this is like a bridge, that means that is connected like that, and say this is the corresponding battery E, so this is resistance R1, resistance R2, this resistance R3, this is a resistance R4, and say there is a galvanometer, and this galvanometer has also some resistance, this like that. So if this type of circuit is given, then the current distribution is one of the important thing, because if you cannot, branching the current in a efficient manner, your number of equations will be much, and that will take time to solve. So that is the problem. That means if you are not considering the distribution of current in a well manner, then the problem comes that you have to solve a greater number of equations. So now if we start from that, say the current I, say you say this is the current I. Now you will say that current I is divided into two parts, and since we don't know that whether this is a symmetric or not symmetric, so we are not divided it equally. And of course if we say the current I1 will be passing through this, so the remaining of the current, that is nothing but I minus I1, that will be passing through this. And say after going through I, say it will be divided into two parts. One is say Ig, and say this is nothing but I1 minus Ig, because the rest of the amount I1 is divided into two parts. One is I1 minus Ig, that will be flowing through R2, and one portion is Ig, that will be flowing through the galvanometer. And at that particular point, this current and this current will be matches, and actually the current that will be passing through that is, you just see, I minus I1 plus Ig. Now at that point this two current will again matches, that means I minus Ig, that should be matches with Ig, I1 will be cancelled out, Ig will be cancelled out, and I will be full. That means your current distribution is correct. That means what current that will be entering, the current will be the same that is leaving. So now if we apply the Kirchhoffs law, say this point is A, this point is B, and this point is C, and say this point is D, and of course that is E. So if we consider the loop, say A, B, D, A, like that, that means we are coming to A, this is B, this is D, and this is A. That means that loop A, B, D, A. Now if we considering in that particular directions, I am saying that you can take in either way. That means in the previous case what I am taking, that when we are moving in the directions of the current, then what we take here, if we move in the same directions and the directions of current, then we are taking as a negative, I think. So here in that particular case you will see, when we consider this this 3 ohm resistor, you will see that we are moving in this directions and the current directions in its opposite side, so you are taking as a positive. And when we are that is also in opposite side, that's why this is taken as a positive. So if the direction of the current that will be opposite directions at which we are just traversing the loop, that means in that particular case you will find this is I1, and we are traversing in the same directions, so that means you can take as a negative. Now there is a resistance which is Ig, I am taking as a Z, this resistance is G, and since when we are moving in that particular directions also, you will see that Ig and the loop directions that will be in the same direction, so that is Ig into G minus, and when we are, you just see I minus I1 should be in that directions, and we are moving in that direction, so that are in opposite directions. If this is our opposite direction, we are taking as a positive, and there is no voltage is associated, so you can take as a 0. So what we can write from there, that means if we take say minus I1, this is a I1, and no, I am writing wrong. This is something R3. Okay, this is R3. So this is R1, plus R3 minus Ig into G and plus I into R3, that is equals to 0. And if we consider, the loop BCDB, that means this is a B, this is a C, this is a D, this is a B. That means we are moving in that particular directions. We are moving in this directions. So that is the same case. That means that is the opposite. That means in the same directions, if we are moving, we are taking negative. In opposite directions, you just see we are moving in that particular directions, and so in the opposite directions, that is taken as a positive. So I minus I1 plus Ig into R4 plus, we are also moving in the opposite direction. That means that is Ig into G is equals to 0. So from that you can also minus I1, this is R2 plus R4, this is plus Ig, we can write R2 plus R4 plus G. So I R4 is equals to 0. So this is the equations number 2. Say this is the equations number 1. So the thing is that if we divide the loop in that particular fashion, then it will be okay. Now the thing is that there is a conditions, that means that is called balanced Wheatstone bridge. Balanced Wheatstone bridge network. That means when this voltage, potential voltage and this potential voltage are same, that means at point B and D has the same potential, that means that is a balance, and that means the current Ig should be equal to 0. So balanced Wheatstone bridge network, that means the current through the galvanometer is 0. Now if you can put the value, Ig is equals to 0 in equation 1 and equations 2, you will get this R1 plus R3, that is equals to I of R3, and from equation 2 we will get I1, this is R2 plus R4, that is equals to I into R4. Now if you can divide it, then what you can get, this is R2 plus R3 divided by R2 plus R4 is equals to R3 by R4. Now if you can solve it, then you will find that relations can be written as like that. That means if the resistance ratio is coming out like that, then what we will find, then there should be no current that is passing through the galvanometer, and that is one of the important thing that you should know. That is nothing but the balanced Wheatstone bridge network. And when the balanced Wheatstone bridge network will occur, that means the current through the, if the current is 0, that means you should not take the resistance also, and that would be, there are lots of problems that can be solved by Wheatstone bridge. If you are doing the normal way, then you will face the problem, but if you just apply the balanced Wheatstone bridge network, then you will see the problem will be solved is more easily. So you should remember that is a particular conditions, and if some questions it may be given that balanced Wheatstone bridge is not given, then you have to do this particular current distributions. That means it may be possible that you are distributing like that. That should be number of ways you can distribute the current, because if we say there is a current I1, there is a current I2, then this is divided into this is a current I3, this is a current I4. If you divide like that, then there are lots of equations that you have to solve, and that is a problematic manner, because that amount of time you will not get. So the thing is, you just look about the current distributions, and it would be always better if we distribute less number of variables. If you are distributing the current such that you can use the less number of variables, then you need to solve the less number of equations like that. So that is one of the important thing in KVL. So I think up to this, that is clear or not?